Hi, this is Mrs. Dorenkamp. I just wanted to talk with you today about scientific lab expectations, basically how to complete a lab write-up in my class or Mrs. Robson's science classes. Parts of a report, you're going to have several parts to your report. You'll have your title page, the introduction, the methods and materials, the results, the discussion, and the literature cited, or as we usually call it, our source cited page. Okay, so on the title page, basically it sounds kind of weird, but do your title page after you have did your complete lab write-up. Okay, so you can go back through and you can be thinking about it as you're doing your lab write-up, what you want to name your report. Okay, so capture the main point of the lab. If you want to do something fun and, put a twist on the words, that's fine. Your clear, concise title, though, will go here. Your name, you most likely won't have lab partners, but if you do, you'd put your lab partners, the name of the class this is for, and then the date. This would all be on your title page, okay? Next, so this is the very first part of your lab write-up is the introduction. It's usually several paragraphs long. It should tell why the study was undertaken, a brief summary of relevant background information, and end with a statement of the specific problem we're examining. So when appropriate, near the end of it can include your hypothesis formulated prior to the experiment. Kind of a little helpful tip here is the introduction. If you look at your lab write-up, a lot of times it will tell you the purpose of the lab. You can look at that and write in your own words the purpose of the lab as your introduction. Again, use your own words for this, okay? So what is the big question? Why are we asking it? How will we answer our question? So what particular methods are we using to get at this question? Why these methods? What do they show? What do we expect? So what do you predict will happen? And then, of course, why do we expect this hypothesis? And remember, your hypothesis should be in the form of an if-then statement. Okay, so if we add fertilizer to the plants, then they will grow significantly. You could give an amount they would grow. You predict that they would grow. Okay. Your methods and materials, check your lab manual because it's probably going to have both of these kind of outlined for you. Materials definitely will have listed for you. Methods, and that's basically the methods you use to go through the experiment. Okay, so this could be anywhere from a half page to 1.5 pages long, depending on how detailed the experiment is, how long the experiment was, how many materials you use, that type of thing. Okay. Now, this is a biggie right here. References are absolutely necessary. You didn't design the lab, so you can't take credit for it. Alrighty? So, have a concise explanation of materials and procedures. You may want to include a small figure if a procedure involved a weird, complicated setup. Okay? Next, a little more after you've put on your methods and materials, you will need to look back at your lab and start interpreting the results of this lab. Okay, so this is the base of the report right here. Oh, it keeps moving me. Okay, do not underestimate the weight of the results section. The data clearly presented are the single most important part of a good report. Without good results, you cannot write a logical discussion, which is the other big part of your lab write-up. Keep the big question in mind when organizing this section. So this one's going to take a little bit to organize and do, okay? In the results, text is a summary. It's not an interpretation. We want just the facts in the results, okay? Let's see here. All of the following are appropriate in your results section. A written description of your figures, the figures themselves, sentences like, feeding rate increased as temperature increased, as seen in figure X. That would be a good example. Figures, so tables and graphs. So focus, what is the best way to show the trend in your data? Of course, on each axis of your graph or your table, you have clear, concise labels, avoid excess words. Labels must have units. So you can't just have 5, 10, 15, 20. It must be 5 millimeters. You need to put whether it's in millimeters, centimeters, kilometers, whatever you're using, okay? The legend is not a repeat of both labels. It actually tells you what is what. You tick your mark labels, make sure that you have definite true spacing between each tick mark. Spread it out. Info per unit is horizontal in a graph. If you can't read it, I can't read it. So make sure it's legible before you send it in. Okay. Titles for figures. Number and title are necessary. For example, a figure 1, you'd put the words figure 1, colon, mean number of nodules produced in each of 3 treatments, low light, moderate light, and high light conditions. Or for your axis labels, for example, like I was telling you, time in minutes. You have to have units. pH, blood glucose, milligrams per milliliter. Temperature, degrees Celsius, product, milligrams, absorbance, 400 nanometers, things like this. These are all great examples. Okay, so now let's go ahead and get to the other big part. The results was a big part. Now the discussion tells about those results. Okay, it's your interpretation of your results. Why, not what. So why this happened, not what happened. Okay. You told us what happened in the results. Now you're telling us why. You're going to convince the reader that you are interpreting the data fully and intelligently. This will usually be 1 to 2 pages long. Longer is not always better. You might go ahead and most of my lab write-ups and most of Mrs. Robson's lab write-ups will tell you exactly what questions need to be answered. It's usually in the lab report itself. Okay, so when you are the instructions for how to do the lab, we're going to ask you what questions or tell you what questions you need to be answering. But in the course of it, you're probably going to be also telling us what did you expect to find, your predictions, hypothesis, and why. How did your results compare to what you expected? How might you explain an unexpected result? How could you test your explanation for this? How could you improve this experiment if you were to repeat it? And then, of course, the biggie, citations are a must, okay? As is a good set of background information, okay? As is a good, it's really great to cite your sources. Of course, points will be taken off if you do not cite them. So here's how to cite your sources, which I also did another video on it that gives you a little more details on exactly how to use different types of sources that you've researched, how to get them in there. So give credit where credit is due. Let's not plagiarize. Proper format makes a good, clean report. For example, in the body of the lab report, the sky is red at sunset due to the refraction of light off particles of pollution. And then there is, looky there, you have a source cited within your report itself. Then at the end of the report, you have your bibliography or your literature cited, source cited page section, specifically formatted and alphabetized by author, and it would look like this. Okay, so give credit where credit is due. Alrighty. So here are just some extra tips for you. These 2 words mean 2 totally different things, but are both accepted by spell check programs. So make sure that you read your paper, maybe have somebody else read your paper to make sure you don't have spelling errors that spell check might not catch. Of course, your scientific names are always italicized and one capitalized and one not capitalized, such as Homo sapiens. Proofread, this is what I was talking about a minute ago. Proofread, swap papers with someone, make sure they can make sense of your lab report. This makes a big difference in quality and grade. Also, you can check those little misspellings that spell check will just jump right over. Be sure each sentence actually says something relevant, otherwise get rid of it. Okay? This is a kind of a big one. Use words, not numerals, when beginning a sentence. So if you were to write 4 milliliter samples were removed from each flask, you would write it as FOUR rather than the number 4. 2 in a row, okay? So use words, not numerals, when you have 2 things in a row. So we place 5 6 seedling pots in the greenhouse. Do you see where we wrote out 5 and then use the numeral 6? So you will have one of them will be written out, the other one will be a numeral. Instead of we place 5 6 seedling, because that makes it really difficult and kind of hard to understand. The other option is to rewrite the sentences to avoid both these situations. If you don't want to worry about when you start with a number, start a sentence with a number, or if you have 2 in a row. So this is another thing for some clarity, just to make it easier to read your report. Always precede a decimal with 0 if the number is smaller than 1. You would use 0.57 grams instead of 0.57 grams. Okay. Most important, Let me move this over. Keep the focus on what will answer the big question. What is the focus? Proofread, proofread, proofread. Don't procrastinate. Lab reports take a couple of solid hours to write if you want a decent grade. Ask for help well before the due date. Talk to your classmates. Be sure to understand plagiarism. When in doubt, ask. Better to oversight than to not cite. We always want to give credit where credit is due. Alrighty, now if you have any questions, just ask your teacher. We are here to help you. This will also be embedded in our courses. Thank you for listening and have a great day.